A box contains 100 envelopes. 10 envelopes contain $10 each in them. 10 contain $5 each in them. 2 state that you must pay $50, and the rest are empty. So we're going to draw an envelope from this box, and we want to determine what our expected value is. Alright, so in order to determine what expected value is, we have to take the amount of payout, how much money we're going to receive on this, and multiply that by the probability of each one of these events occurring. Okay, so we are expected on this one, we've got 10 envelopes that contain $10. We're expected to earn $10 if we can get one of these 10 envelopes. So the probability, so we'll take this $10, multiply that by the probability of getting one of these 10 envelopes. So that, let's see, 10 envelopes are 100 total, so 10 divided by 100 would be our probability of getting just this $10 payout. Then we also have a $5 payout for another 10 different envelopes. So we've got 5 payout. This is going to be a positive 5 because we're also still receiving that 5. And we're going to multiply that by the probability of receiving one of those envelopes that has the $5 in it. There are 10 envelopes that contain $5, 100 envelopes total. So that would be 10 divided by 100. Again, we have the same probability for either one of those, although they have different payouts. The next one becomes a little bit more interesting because 2 of these envelopes state that we have to pay $50. So we don't want to get one of those. We've got to calculate what the probability is of getting one of those and what the expected value would be. Okay, so if we're going to pay $50, that means we're actually going to subtract 50. Subtract $50 times, and we're going to multiply that by the probability that we're going to receive one of those envelopes. And it says that there are 2 of those, 2 out of 100. So minus 50 times 2 over 100. Now we're going to plug that and just plug all of that into your calculator, just like you see it right there. It works just fine. I recognize these are not reduced, but that's okay. Your calculator can do it all for you. Your calculator will tell you that your expected value is 0.5. So if we play this game all the way through, and we have to, even if we eat 2 of those that have $50 in them because we drew those 2, but if we draw all 100 of these envelopes, our expected value would be 0.5. The only ones we didn't account for in here are the ones that don't contain anything because they are empty. We could have done that. That would be plus 0 because our payout would be 0. And then multiply that by the probability of getting one of those that are empty. And let's see, there are 22 that have something in them. That means that there are going to be 78 that are empty. But it'd just be 0 times that, so it would be 0 still. Now, if we change the question just slightly, we're using the same scenario as we did up here. The only difference is now that you have to pay $2 just to play the game. So before it worked to our advantage because we're going to get an expected value that's positive. It's going to be 0.5, equivalent of 50 cents on this one. If we play it enough, now we have to pay $2 to play this game. So if we have to pay $2 to play it, that means our expected value is going to be the exact same here with one slight variation. That is that we're going to subtract $2 because we had to pay $2 to play this game. So now we're actually losing $1.50 every time we play that game, assuming that we play it over numerous occasions. Okay, not just one time because that would be a different probability. But if we play this a lot, if we're playing this all day, every day, we'd have an expected value that's negative. We're going to, on average, lose $1.5 every time we play it.